Hey guys, so today we're going to be doing some practice problems with converting moles to grams and also to particles. So there's a couple single step equations on this slideshow. And then there's also, I think they're all single step equations. Yeah, so no worries. Okay, so this, hey guys, so today you guys are doing a moles to grams assignment. These are all going to be single step equations. So I know that there was a double step equation or a two-step conversion in your notes, but the practice today is all going to be single just to kind of get us a little bit more acclimated to these before we do the more difficult problems. So what I'm going to do is I'm going to zoom in just a little bit on this, and I'm going to give you some examples of how to do these problems. Okay, so we have these slideshows here, and we are going to do some of these conversions. Now I'm going to zoom in a little bit just so you can see it a little bit easier. So there are 2 slides with 12 problems total. Now thankfully the first slide will go a little bit quicker because you have some options here that we're going to drag and drop. And then the second slide gets you started with what we know, and then you'll have to figure out the conversion factor, okay? But the first one will be a really good help and examples for those conversion factors. So let's take a look at this together. So for each of these, we're going to drag the conversion factor over, which I'm going to show you a really easy way to do it. And then you guys will just have to do the math through. So we'll need to definitely have either your calculator pulled up if you have a calculator at home, or of course Desmo Scientific will always be a good option as well. Okay, so here we're converting moles to grams or grams to moles. You can do it either way based on the conversion factors. So whenever we're doing these, of course, we start with what we know, which thankfully this already has it for us. And then we need to drag our conversion factor to our T-chart. Okay, so we're going 5 moles of carbon to grams of carbon. So here we're going moles to grams. Now remember, when we're looking for a conversion factor, we're using the average atomic mass from the periodic table. So we'll also need p-table pulled up. Now for these first 6, it has the conversion factor for you. You just have to choose the correct format, and I'm going to show you the correct way to do it. So remember, when we're setting these up, we always want the unit that we're eliminating to be on the bottom, and we want the unit that we're ending with to be on the top. Okay, so I know I'm starting with moles and I want to end with grams. So when I'm choosing my conversion factor, the grams need to go on top and the moles need to go on the bottom. All right, so if I'm looking here at this first one, I'm going to choose the one with the grams on top and the moles on the bottom, okay, because that's my conversion factor, and I'm going to try to get this centered with my T-chart, okay? So 5 moles of carbon, and then times, it'll be 12.01 grams of carbon over 1 mole. So if we see here, if we can imagine this, the moles are going to eliminate, and then my 12.01 grams, my grams will be left on top, okay? So when you're doing these, it doesn't matter if you're going from moles to grams or grams to moles. Whatever you want to eliminate should be in the bottom. So like, for example, let me find one with grams. So number 3, we have 814 grams of calcium hydroxide here. So for this example, because we want to get rid of grams, we want to choose the factor that has the grams on the bottom and the moles on the top. So for this one, the grams need to be on the bottom and the moles need to be on the top. Okay, so that's it. That's all you're looking out for these. So for these, when you're choosing what unit you want left over goes on the top, what you want eliminated goes on the bottom. All right, so now let's do the math for these. So again, this is just fractional math. So what I like to do is multiply through the top, then multiply through the bottom, and then divide. Okay, so it looks like I have 5 times 12.01 on the top, divided by 1, because we're assuming a 1's right here, times 1 mole. So since I know the bottom's going to be 1, we don't really have to worry about it. So really what we're doing here is 5 times 12.01. So I'm going to go to my calculator. 5 times 12.01. Our answer shows up here, it's 60.05, right? So for my first answer, I'm going to put 60.05 grams. No naked numbers. If you guys don't put your units, I will be taking points off because we need our units. No naked numbers in chemistry ever. Okay, so that's how you do the grams or moles to grams. So now let's look at a gram to mole problem. Here we have 814 grams of calcium hydroxide, and then we've got the 74.10 grams that we're converting to moles. So we're going to divide here, all right? So if we can see this, 814 times 1 on the top divided by 1 times 74.10. These are just fraction problems, okay? So I'm going to go back to my calculator, and I'm going to clear it. And again, we had 814 divided by 74.10. So 814 divided by 74.10 is going to give us 10.985. And I'm going to round this to 10.99. So I'm going to go back and I'm going to say this one is 10.99. It's not grams, it's moles. Okay, so we want to make sure we're keeping our units. So again, here you are just choosing the conversion factor. We want to make sure what we want to end up with. So grams or moles are in the top. And here are grams eliminated, here are moles eliminated. Okay. For a mole to gram conversion, you're just multiplying across the top essentially because the bottom's always going to be 1. But again, like here in this example where we're going from grams to moles, you're going to have to do some division. Okay. So that's the first slide. It should go super, super quick because you already are given the conversions. Now let's look at the second slide. Here we're going from moles to grams and grams to moles again. But in this case, you guys are going to have to find the molar mass, okay? Remember that comes from your periodic table. So let's do this one together. Let's do grams of water. So we're going from grams to water to moles of H2O. Now with this one, if you guys click in the boxes, you'll be able to type, okay? So let's go ahead and type in our units. So we're going from grams to moles. I know I want to finish with moles, so my moles will be on top and my grams will be on the bottom. Okay. And I also know that I'm always going to have a 1 with my mole when I'm doing a conversion factor because 1 mole will always be equal to something, right? 1 mole is equal to 6.022 times 10 to the 23rd, or 1 mole is equal to the molar mass of whatever compound we're working with. Okay. Next, we have to find our molar mass of our water. So it's H2O. So let's go to our periodic table. So we have to do 1.008 because that's the average atomic mass. So it's 1.008 plus 1.008 because there are 2 hydrogens in H2O. Plus, let's go back, H2O, the last one's oxygen. So let me find oxygen, plus 15.999. So 15.999. Okay, and that's going to give us 18.015. Again, what I just calculated here is the molar mass of H2O, right? We have to take the average atomic mass of the element, and then we need to add them all together in the compound, right? So 1.008 plus 1.008 for those 2 hydrogens, plus 15.999 for the 1 oxygen, which will give us 18.015. Okay, so that's 18.015 grams of water. Okay, our grams are going to eliminate. And then we're going to be left with moles, which is exactly what we want. So here we're going to do 2,700 times 1 divided by 1 times 18.015. So let me go ahead and clear this, show you how I type that in. So 2,700 divided by 18.015. Oops. Will give us 149.88. So I'm going to do 149.88 moles. Okay. Again, what this means is that if I had 2,700 grams of water, that means I would have 149.88 moles of water. Okay. Now let's do a mole to gram of one more. I'm going to do the ones that have multiple multiple elements in the compound, just to help you guys visualize how to calculate again. So again, now we're going from moles to grams. So I'm going to want my grams to be in the top this time because that's what I want to be left with, and my moles in the bottom so that they'll eliminate. So I always have a 1 with my mole. Now I have to figure out my molar mass. So I'm going to add 2 atomic masses of sodium because there's 2 sodium and 1 oxygen. So let's go to our periodic table. Sodium is 22.990, so I need 2 of those. So 22.990 plus 22.990. And of course, you could do 22.990 times 2. That is something you absolutely could do. But I'm just trying to help you visualize it because there's 2 sodiums and then 1 oxygen. So there's the 2 average atomic masses for our 2 sodium, so 22.990 plus 22.990. And then our last element in that compound is oxygen, so 15.999. Which is 61.979, which is our molar mass. So we're going to put 61.979. Okay, and here, again, we're just going to multiply through. So 17.2 moles times 61.979 divided by 1 times 1, because there's an assumed 1 here and 1 mole. So these are pretty easy because we just multiply through. So I'm going to go back here and 61.979 times 17.2 is 1066.04. And that is grams. Okay, that means in 17.2 moles of sodium, of disodium oxide, you would have, or sodium oxide, I'm sorry, sodium is a metal. In sodium oxide, you would have 1066.04 grams. So 17.2 moles of sodium oxide would weigh 1066.04 grams. So it makes sense. So just kind of to help check yourselves, if you're going from grams to moles, it will be a smaller number. If you're going from moles to grams, it will be a larger number because the moles, the grams in 1 mole of these substances are going to be higher. Okay, so that's the step-by-step process. Use these examples to do each of these. I know it seems like a lot, but you have to practice. Like anytime we do conversions, practice, practice, practice is all we can do with these to make sure we get them and we feel comfortable with them. Okay, if you're struggling or need help or need to do some more examples with me one-on-one, book a meeting or email me and let me know, and I will get back to you. Okay.